to Pet Cemetery Part 3, and let's kick straight off with me trying to get the Pet Tester ROM up and working.
I really should just start recording from my screen rather than recording my screen. So this is the asm80.com website, which is what's used to compile Dave's test ROM. So here we've got the code in here. So this is the Pet Test A65 source code which he provides. And one of the things he said is you do need to set the CRT controller. You need to initialize it with the correct values for the CRTC that you're using. And I'm guessing, because we're 50 hertz here, so I'm going to go with this PET CBM 50 hertz settings. So we've got all the values here, and we just replace the values that are there, save the file, then we can compile it, download the bin, and burn the bin file onto a 2716, which is compatible without an adapter. So I'm going to do that, and then we'll be able to test that when we get around to it. We are fully rammed, and I think I might be making some progress here. So I've installed all the RAM, still only sticking with the 16-bit for now. I've actually pulled off all the -5 bits there, stick them in the bag if they ever want to go back on. I have put a little 10k cap in here because I've left the capacitors in on the now disconnected rail, and they were starting to build a bit of voltage up. So that should keep it grounded and keep pin 1 just low. I'm sure someone's probably going to tell me I'm about to set it on fire by doing this. And I've got the test ROM in here, which I've set to what I believe is the correct one for the CRTC that I have here. Still completely unsure, and to be honest, a bit out of my depth compiling the 6502 code. However, now I am seeing activity on the CRTC controller here. So we do appear to have activity, and on the pins here where we've got the sync lines going out, I now have got what looks like data. So I think it is trying to display something. The only problem is I have quickly just tried hooking the monitor up that I have, and that isn't starting. It's making some slight whining, but it's not firing up. Now that could be that I'm not generating the right signals for that monitor. I could have got the wrong settings to initialize the CRTC, or it could be, which I'm thinking is possibly more likely, that there's an issue with the monitor itself. I don't think I've got anything that I can get a video signal out on this, so I'm gonna have to have a read up, but it is showing signs of life. It is still only showing 15.0 on that, which is a little bit confusing. So we've still just got 15.0, 15.0, 15.0, 15, so effectively 1 and 0 on the one line. But I'm not really actually seeing any activity on the pin to this, which I would assume if I go 1, 2, 3, 4, 5. It's just high. I thought that was active low. Maybe I'm mistaken. But yeah, so I'm going to do a bit of a read up, try and see whether I can get any kind of display out, because this test ROM requires the display. So it's pretty useless without that. But that's definitely good. I'm now seeing activity. I'm still not hugely happy about the data lines that I can see. I can't actually tell. I'll have to flick the scope over. They're still not going fully between sort of, well, 4 and 1 volt. I'm still seeing them drop down to about 2 volt every now and then. But that could be normal. Anyway, right, I'll try and work out what I can do about the display. I'm back to randomly poking at things to try and spot something that could be wrong. So I've gone back to this 4 to 16 decoder to check over all the lines. Now, we know that this is only getting a signal from ABCD, which is either 15 or 0, 15 or 0. So on 15, pin 17, which is 15, we get that. And on pin 1, which is 0, we get the other side. And if we look at pin 2, that just sits high, 3, high, 4, high. So then we start seeing, I mean, some of them, there might be a little blip of data that we see in the actual trace. But the one that really doesn't look right at all is that. So I need to have a look at what's going on with that signal, because if we trace it up, we come all the way through up into this UE13, which is outputting on pin 6, which goes into UE11 into pin 2. And if we have a look at UE11 down here on pin 2, we can see we have got a signal, but it's starting at about 2 volt. So I think I'm going to trace my way back, because this is what's being fed out of the line here, but this line should be only being produced by the 4 to 16 decoder and going out to these select lines. So I've either got a problem with the first thing which it hits over here, which is this 7410 here, or I've got a problem somewhere on in the select line here. So I'll have a look at both of these and see if I can spot, without removing them, where the problem's coming from. Yeah, we've definitely got a problem here. So we've got a little 10k, just pulling that up to 5 volts, and it's not. It's pulled all the way back down. So we've either got a problem with the input on the AND gate over here, or with the enable pins on the decoder down here. So I'll pick one of them, see if I can lift a leg. If not, I'll pull the chip and probably get the wrong one first time. So that's failed, and that's the NAND chip at UE13 over here, which, testing with a multimeter, had a slightly lower resistance to ground. So that's the one that I've gone with, and it has failed. So I'll get a socket and another one of those in. I should have one, and we'll see if that's fixed that problem. Ooh, progress. So that's back in now, and although it's still not booting off the original ROM, with the test ROM in, if I power this up and if I check on the video output here, I can see that we're getting 20 kilohertz, and that one, if I zoom that right the way out, that'll show 50 hertz. So that's now outputting the correct video signal, I think. So I might try and hook the monitor up, even though I'm not entirely sure whether the monitor works at all. But that's now doing something. Right, one moment. Who'd have thought it? Life. Got absolutely no idea what that means. I haven't got the keyboard hooked up as well. I think it can do a keyboard test, although the keyboard probably doesn't work. But yeah, right, at least I've actually got something, so I can go back to Dave and try and work out what this means. Cracking. What I've done is pulled off the character ROM, and it appears to be completely blank, so that's dead as well. So I've burnt another one. I'm making an assumption because it's a 2316 that, like that one, a 2716 will work, but I will need to double check on the schematic about that. But what that's done now is our sort of blocks of text now have this flashy characters. So that's loads better, and we can see it's attempting to do all of the characters, but like we can see that the B character is replaced with an at. So we've definitely got an issue with some kind of addressing or memory, or probably one of the data or addressing bits. So I can now start having a little poke and see if we can work out which one's bad. The next thing to try is apparently to just drive the data outputs of the character ROM. So we've got all of the data outputs being driven high from this slightly janky arrangement, which should set all of the characters on, so a green screen. But if we have a look, we've got exactly the same pattern. If we flip it over to ground them, we get the exact inverse of that screen. So it definitely looks like something's being held high. And the next thing that's in line is the UA2 chip, which is the one down there, which I might have a little look and see what that's up to, because it could be that that's not decoding the signal properly, which I can probably do by having a look at what the lines are coming in on the inputs and the outputs of that, and see if it's giving the right signal. Let's give that a go. So this is what it looks like when you ground one of the data lines. So you can see there, it inverts one line. And they are all working. So I don't think the issue's here, or even with the decoding, perhaps. There's something else, an issue somewhere else, perhaps in the video RAM or whatever's drawing, so I don't actually know how it all goes together. So let's look for something else. The suggestion on the next steps is to pull more bits off. So you've pulled the video RAM out, and sort of step one is have a look at what's happening with the latch here. That should be latching the data from the RAM. And with the RAM out, all of the Q inputs on this latch are all high, about 4 volts. And we can see the enable signal pulse coming in, and the OC line on this is held to ground, to mean it's constantly active. I think you can do a jumper here for 80 column mode, but in 40 column mode, we're always on. And so what I would expect, unless I'm wrong, because this is just a series of flip-flops, I believe, is that the activity on the output should match the activity on the input. And if we actually check some of these output lines, they look like that, which doesn't seem right. So I'm going to put it off and have a look. Well, I was wrong about this. So there it is now removed. So there's the latch out, and I can still see the signal. Now, according to the schematic here, the LSD bus only exists on the character ROM, which doesn't exist, the 8-bit latch, which doesn't exist, the 2 RAM chips, which don't exist, the odd RAM selection, which don't exist, and then we've got the 2 buffers here. Still trying to work out what the problem is. So I'm doing lots of things like we've got the 2 video RAM chips here, and we've pulled all the data lines down to ground. I know I could just use 1 resistor, but I haven't actually got any spare little bits of wire, so I'm just using resistors instead of wire, and that gives us a load of ATs. So that's indicating that it is reading from the character ROM okay. But I think that means potentially that there's a problem with the character ROM, which is weird because that does verify okay. But yeah, I'll let you know. So, got UC3 rigged up, and I'm having a look at it just to see if it's doing what it should be doing. It's a 3 to 8 decoder, or 8 to 3 decoder, I can't remember which way around it. So we've got the 3 inputs into it, and then we've got a load of outputs, of which we're only using 4, 5, 6, 7. It's got 3 enables, 2 need to be low, 1 needs to be high. And if you have a look at what we're getting out, it looks absolutely fine. So here's the 3 inputs. So they're effectively a data bus, and we can see they're going 26262626 262626. Now, when we hit the 4, we're on the clock cycle here where it goes positive. This is the enable pin that needs to be positive, and we get 2 negatives. So we can see on line 4, we get a negative, which is effectively enabled because they're all high by default. And that's it. The one that I'm interested in is 6. And we can see here that although 6 gets triggered quite a few times, it never gets triggered when the not cell B line is low. So we don't get any output on output 6. So I don't know what that means, but I'll have a little dig. But it looks like that's working absolutely fine. So that's not the issue. If anything, the issue is that not cell 8, I think. Sorry, not B. Looks like a B, not cell 8. So I'll have a little look at what that could be. Getting desperate now, so I'm starting to play with breadboards. So I've got this connected to the data ports on the memory, and with them all grounded, we've got AT. And so I'm just checking what each one of the channels are. So if we undo D0 and pull it high, we get A. So I'm just running through them just to check that they all map to the correct character, which definitely shows that each one of these address lines is working. And if I see one of them that produces the wrong character, then I'll know that something's bridged or I've got a problem. So that's my current thinking. I'll just plod along. Wires. Right, so I am now 100% sure that the data lines from the RAM are okay. Because what I've got here is I'm connecting to the output here, and we've got, so that's the latch. Then I've just got a little breadboard here which is going to the RAM data lines, and I've got this monitoring the outputs there as a bus. And if I set these high, it'll change the output that's on there. And then we can also see over here that this is producing a 16, which is the correct output for the 1 bit being pulled high. So effectively it runs through them, so just on each one individually, so 0, 1, 2, 4, 8, and so on, all the way up to 128. And they're all correct. They're coming out of there. So there's nothing wrong with the data lines on the RAM. So I guess now I need to start having a look at the address lines, or perhaps look at the output of the data lines coming in here into the character ROM. I might have found something. So I'm just checking the multiplexers here, and you've got the 2 inputs. So there's 1A, 1B, 2A, 2B, 3A, 3B, 4A, 4B, and then you've got your 4 outputs. So these are pairs. So you've got 4 pairs there to 4 outputs. And if I have a look at SA7 here, all the rest have been okay. But what I can see is what select line is going, it should be flicking between these 2. So whilst it's low and high here, you expect the outputs, and I'm tracking both the outputs just to check the traces. So both ends of the wire effectively. And this is going high, low, high, low, high, low, high, low, high, low, because we're flicking between these 2 where we're going high, low, high, low, high, low, high, low, high, low. But when we hit this should go high, high. So the output here should be straight high across both of those. And it's not, which means that it's treating 2B as constantly being low. It's ignoring the highs. So I think I might have a problem here with UC10. So I'm going to put it off. Oh, it is a Christmas miracle. Yeah, it's low. Right, I have a spare. I'll test it. Let's get a socket in. Oh, right. Progress. So I think that's it running the memory test. If we give it a reboot, we get the first few screens, which is correct. That I think's like the keyboard test, which isn't plugged in. And then it goes on to the memory test. Now it's still screwed up, so we've still got the A at C, B, E, D instead of at A, B, C, D, E. And I'm still not happy about these. I'm going to pull this one off because although I could see most of the signals on it, there's definitely corrosion underneath it. So if nothing else, I'm going to pull it off, clean this all up and test it. But that's also the same one. There were 3 different types, and that's the same one as the one up here that had failed. So I'm going to pull it off anyway, and we're going to check. Right, I think I'm going to start pulling a couple more chips. Not because I can see there's anything wrong with them, but I'm sort of running out of ideas at the moment. So one thing I've had a little look at is I've drawn some little crosses here on failed components, and we've got obviously failures for the CPU, of the decoder. We've got one of the little logic chips there. We've also got them coming into the quad 2-to-1 MUX chip there. And then we've also got it coming into the RAM. Now the RAM feeds into these. This feeds into here, which is also connected to this. So we've got a common connection, and this also connects up to here, and then these would connect to here, but they'd go through these buffers here. So we have got a common connection with all of these, even if we have a look at the failed EEPROM. That one is on one of the select lines, which feeds back to here. So it does like potentially we've had a power spike go through. So a lot of them run through UD14. So we've got these lines here, we've got these lines coming up to here. So I'm going to pull these 2 buffers anyway. Me and buffers don't get on. It's always the last one that I look at that has a problem. So while I've got the desoldering gun out, I'm just going to pull these two off and we're going to test them. If nothing else, it will give me some good points to test from, and also it will eliminate sort of this side of the board. So I'm going to take them off and have a little look. As always with anything buffer related, it definitely won't be those because there's still more buffers. So those ones are okay. So if it is one of the buffers, it's one of the other ones. But I can now rule those out. I'm not happy with the socket here. I have reseated this character ROM, but you can see if I press it, I'm getting issues. Now, it wasn't quite this bad, but I have been jiggling it about. So this is one of the original sockets. So I'm going to swap that out for a new socket. Just because, I mean, the lines like that almost look like that is a sort of similar issue with it bridging the data lines or the address lines. But I'm going to swap that out. Right. Okay, it's got a nice new socket now. And now if we give it a poke, we're not getting corruption. So that's a lot better. Hasn't fixed the problem, but wasn't really expecting it to. Okay, so gonna need some more poking and prodding, try and work out what's going on with this address line 0. I am still getting nowhere. So I'm gonna pull out the flip-flops, which are these ones, because it seems like a timing issue, and I've checked pretty much everything, and I've checked the flip-flops and I can't see anything wrong with them, but I'm really clutching at straws at the moment. So I'm going to pull them out and we're going to see if that makes any difference at all. No big surprise there. They both test fine. I might swap them out anyway, just to double check. But yeah, not them. We have actual progress. So the character ROM, which is there, which is a 901447-10, we'd burnt that onto this, which we can read in the reader, and it also reads in the retro chip tester correctly, 90144710, and that worked absolutely fine. So we read back the contents using the burner. However, I was really running out of things that could be the problem. And if we look here, whilst we've now got a load of noise on there, it's correct. So we've got A, B, C, D, E, F, and we can actually read it. And all I've done is burn another one onto a different chip. So for some reason that 2716 works, that 2716 does not work. Could be a timing issue. But yeah. Right, so now at least I can try and move forward a little bit, and we can see what this actually says. We can see it's going off the edge a little bit there. So, right, progress. Just to make sure I haven't got a timing issue, I've got a 27512 win bond, which is loads faster than any of these. I've chucked 32 copies of it on here, so the only thing I've really done with this is just make a little adapter, bump the VCC pin over. I'm not too fussed about the others because no matter what it accesses, it's going to hit a copy of it, and that's quite a lot better. We've still got noise, but nowhere near as much, but we've still got everything shifted over one, so we're not starting with at, we're starting with A, and we can see here that we've got them sort of spilling over ROM. So still got an issue, and I don't think it's related necessarily to the character ROM, but there's definitely something weird going on, because we couldn't use this one. This one doesn't show any of the artifacts, but we have got that inverted signal. Okay. So what I'm having a quick look at now is if we have a look at the data lines on the EEPROM that appears to be too slow, and if we have a look at what it's outputting, we've got a relatively clean signal. And the screen's clean, but we've got these corrupted characters and they're back to front. Now, if I swap this one out for another different brand of 2716, then we get loads of noise on the data lines going out from the character ROM, but we don't have the garbled fonts and we don't have the back to front characters, but we are missing the first character in the line, which actually it does look like we're missing here as well, because we can see that the line's actually starting here. This is ending in an at. So I'll show you what that looks like. Bear with, I'll swap it. And we swapped. So we've got all this noise all over the screen, but we can read everything, and we've still got the issue here where things are on the wrong line. And if we have a little look at the data lines that are coming out, I don't know if we can see there, but they're very noisy. We've got a load of signals that are sort of about 3 volts, which we shouldn't have. And if we swap this out again one more time, bear with. So we've now got the WinBond EEPROM in, and that's looking loads better, but we've still got these little bits of noise. And they are just interference. If I grab the chip here, I can cause more, or in some cases I can get it to go away. So I'm not too fussed about the interference at the minute, but I do need to try and work out why things aren't displaying correctly, why we're missing our first character, which is bumping everything back one. I thought I'd go back over the master timings, so I didn't show any of that. Now, one of the first things I tend to do with a board like this is I'll obviously check the voltages, we'll check the resets, we'll check the clocks. And in this case, this has got a full master timing sheet which shows all the different clock signals. So we've got over here, we've got the clock 8 or clock 16, depending on whether you're running in 40 or 80 column mode. So running through all of these, we've got 8 megahertz where we should, we've got 16, we've got the clock 1s here running at 1 megahertz, clock 2 running at 2 megahertz. Then we've also got the RA1 to RA7, where we step down each time, halving from 500 kilohertz down to 7.8. So everything's looking absolutely fine. And you've got the up here, we've got the 8 phases of clock 1. So that's the 1 megahertz clock. And what that means is if we hook the test clip up to UE3 and we have a little look at it, what we see is each clock signal just slightly phased out. So that's what it means by the 8 phases, that each one is slightly more advanced than the other. So that all looks exactly as it should. So we definitely don't have, at least on the face of it, any issues with any of our timings from what I can tell. Well, miracles do happen. So this is my 4th different attempt at a 2716. So this particular one is an ST M2716 FI, but this is the fast model, and this one is displaying correctly. So we've got the at to start, everything's on screen correctly. We've still got a little bit of interference, a little bit of flickering going on there, but that, I mean, I'm confused as to how this can be that sensitive. Like I said, I've tried 4 different makes of 2716s, including the Winbond 27512, and it's only that one that's actually producing the correct image, which means that I've also tried 4 different sets of the video RAM. I've actually doubled the sockets up here because I was pulling them out so often, didn't want to damage the main sockets I had, and I couldn't get that to make any difference at all. And then after trying my sort of 3rd one of these, I assumed that, yeah, maybe this really is an issue with the timing, like the column timing, rather than the standard response times of the RAM. But yeah, there we go. 16K of DRAM memory test. So the next thing, I'll put the other ROMs back in, but at the moment now, all the ROMs seem to be testing okay. The PET test runs through all its tests absolutely fine, but it doesn't boot. Or at least it definitely didn't. So maybe there's some weird thing going on with the timing of this that's actually impacted the rest of the system. So let's swap the PET test ROM back out for the original and see if we make any progress. Nope. Nothing. So yeah, I'm not sure. I'm gonna have to go and have a read up and see what that's actually attempting to do. Yeah, don't like that. Right, turning it off. Well, that was a bit uneventful. Dead UD7. Now, I'm sure I'd checked that in the retro chip tester, CSE, but there we go. We're booted. Now, I'm fairly sure. It's not looking too bad. Oh yeah, there we go. There's a few keys. Just press it really hard. Oh no, that's not what I pressed. Okay, so the keyboard's still not brilliant, but that's working. Okay, that's great, but also really annoying. That most of my issues were just caused by this edit ROM, and I didn't need to actually remove any of this. There we go. Right, I'm gonna disconnect all of this. I'm gonna put these back in to the sockets correctly, and then we can start putting this back together again. Right, back in a moment. Better give them a clean up. They're pretty manky. We're working. Right, well, I'm going to leave that here. There's probably still a bit more testing that I need to do on this. I need to fix the AT key, and need to try and work out how I'm going to load software on that. There's a few different options, but I'll work out what I'm going to do. I might get a floppy drive unit for it. I don't know. I don't know what I'm going to do with this yet. But yeah, this has gone on long enough now. I've also got the RAM upgrade, where I've done all the sockets for it, so that should be nice and easy, and we'll have a little go at that. But thanks for watching if you've been watching this long. Yeah, who am I kidding? Of course it's not working. So the IE8 488 interface, which we kind of need because that's basically anything that we can use to get data in from the rear of the machine. And there is a program which you can run, which is slightly modified here, but doing the same thing. And when you run this, it will attempt to write to each one of the data in lines here from the 6520, and then it will check to see whether it's written correctly. And we're getting a value of 4 in this, which if I bother type the whole thing in, we can say that if it's greater than 3, then it's bit 2. So we've got a bit 2 error. Bit 2, which corresponds to DI3 because it starts at 0. And we can see that we've got a problem here. So if we, it's a bit dark in here, if we pop a test clip on that and then we run the program, we get something which looks like this, where we can see that we get the data lines go low on all of the DI lines, all of them apart from DI3, which matches the error message that we got there. So either this is faulty, or we've got a problem between here. So I'll have to have a dig. I've done a bit of poking, and what I found was that the data out the DO3 line was being held low, which isn't the same as any of the others. And so I've added a bit of pin strip in here and removed the lines. These are actually the two. That's the DI3 and DO3. That's just instead of bending the legs off this, because if I bend the legs on this, they will snap off. They're pretty rusty. And what that showed is that this is being held, or at least it's trying to hold it at 4 volts, and the minute we connect it up, it's getting grounded, and that will be grounded by this fella at the back here, and that's the MC3446, which is a bus transceiver. Unfortunately, they're now quite rare, and I don't know if there's any alternatives. So I'm not entirely sure I can test them either, but I'm going to pull it out and probably bite the bullet and buy some overpriced old chips. I'll be back. Bloody scope's died again, and the thermal camera says it is one of these. Those little 16AF regulators, which I've got a load of. So let's see if we can sort that one out as well. Get it back up and running. Just got it on a hot plate just to warm it up a bit. It's got a really big ground plane, this, probably to reduce interference, but yeah, see if we can get that working again. Okay, we swapped. There's another one there, which presumably hasn't failed yet, but let's pop this back together again and have a look. And we're back. So if you've got one of these Kiprim DS1202s and it stops working, it's the crappy voltage regulators. Okay. There's the sockets. There's the 3 there. I can swap them about and give them a test, but I'm pretty sure I need to get one anyway, so I'll probably wait for some replacements to turn up. But yeah, let's see if that's made any difference. So my eye-wateringly expensive replacements have turned up, and what I've done as well is I've moved the one from this position over here on the left into the position where we had a faulty one. We've run a quick test and that has also returned faulty, so we've replaced it with one of the new chips, and that is now showing 0 as so that's good. But what that does mean is that it looks like both of these two here are faulty and the one here is okay. So I'm going to have to put another one in there, which I have got. I did buy 2 of them. And then we'll run the full set of tests and make sure that it's all is well. Right, so 1 step forward, 1 step back. So the next bit of code, which is here, where we check the NDAC signals. Yeah, NDAC is bad. And one thing which I did do is we dumped the test clip up and we had a little look at the signals that are coming in, and they looked like this. So we could see the signals being sent through, but when they're being read back, they were not being read back correctly. So focus. I popped in another 6522 in its place, and also one thing which I was going to look at is I bought a new piezo in case this was working, because there was nothing coming out of that. And if I power it on now, we're working. So that's dead as well. I'll rerun the code to see if just to double check it. So I'll type that all back in again, but hopefully that might be the last dead piece. Right, 1 moment. Yeah. So the code's sort of been cut down because I'm lazy. And that's good. That's good. It's good. Bad. Good. So that's the ATN line. That should be 128. So I've got a problem with ATN. So that's the last thing then, hopefully. So I need to try and work out what's going on. No, I had a typo. It's working. Everything's working. So what I really need to do now is get the floppy drive working, or something working, or some way of getting something onto here. But that does appear to be completely repaired. So thank you very much. Cheers for watching.